All right. One of my favorite things to do here in math, in any math class, is applying mathematics in a meaningful way in a real life environment. And that's what we're going to do today. I'm super psyched about this lesson. I hope you are psyched as well. So we're going to build some models from verbal descriptions. Written descriptions? I don't know, whatever. Anyways, we're going to do a little bit of review first. So the first one here is write the cubic equation in standard form given these zeros, 3 and root 5. So if we have root 5, we should also have negative root 5. Don't forget that, right? So I'm going to have my cubic equation here. I'm going to go with, I'll call it f of x equals, how do we go with, let's see here, x minus 3. Then we'd have x minus root 5, which is this one, right? And then I'd have x plus root 5. Wonderful. Now it says standard form. This is factored form, so I got to go a little further. I'm going to multiply the ones with the root 5s in it first. So I'll have x minus 3, and then I'll have x squared minus 5. How did I know that? Well, I knew that the negative root 5 in x and the positive root 5 in x would end up canceling, so I didn't even deal with the inner and the outer. Look for those difference of square patterns. All right. So now I need to FOIL this out. I'm going to have x to the third from x times x squared. Then I'll have, and I'm going to be a little creative with this, x squared times negative 3 is going to give me the negative 3x squared. Then I'll have x and negative 5 to give me negative 5x. And I know I'm a little out of order of normal FOILing, but I did this so it would end in standard form and I didn't have to write it again. How smart. I know. I'm a genius. And one day you can be too. Okay? All right. Let's head into some application. All right, so we're creating a rectangular garden and have 44 feet of fencing. This seems real. I mean, I do have a garden in my yard, and actually it probably is about 44 feet of fencing. All right, express the area A of the garden in terms of its width, X of the rectangle. All righty, so that's our first part here. And then, I mean, if you're going to be making a garden, are you going to want to have the least amount of area you could possibly have, or do you want to maximize that space? I want to maximize my space, okay? So I have a feeling that might be what we're going to do here, okay? So, yep, look at that, maximizing the area of an enclosed fence. All right, so if I don't know the other dimension, I'm going to call that y. All right, so then my area of this is going to be area equals x times y, okay? That, or yeah, there we go. And then my perimeter, how about my set? This would be another equation. My perimeter would be 2x plus 2y, right? Yeah, because I'd have x over here and y right here. Okay, and I actually know what that perimeter is. It's 44, isn't it? So that's pretty cool. Maybe I'll actually keep the p there for now, and then I'll rewrite it. So 44 equals 2x plus 2y. And I'm going to use these two equations together to figure some things out. So I want to maximize my area, right? I want the biggest garden, or most room for my fruits and veggies as possible, usually just veggies, I think. But I don't know, maybe growing watermelons. Got to have some space for that. So what I'm going to do is I'm going to try to get my area function to be a function just of x, right? I want this to be a of x, which equals x times, well, what if I got y to be in terms of x over here in my perimeter function? I like that idea. I could subtract 2x and have 44 minus 2x equals 2y. Then I can divide by 2 on everything, and I'll have y equals 22 minus x. So now I can substitute that in right here, 22 minus x. Well, what kind of function am I going to have here if I were to multiply everything out? I'd have a negative quadratic function that I'm dealing with for my area formula. So this is fantastic. This takes care of this one here, the area in terms of x. All right. So now what we want to do is we want to graph it in our calculator. So grab that TI-84, YORO, and let's plug it in. So now what I have here, it would be, let's see here, x, and then parentheses, and then 22 minus x. All right. And we're going to have to adjust our window, right? So we're going to graph it. I'll hit graph. But we're going to end up having to, if I can actually hit the graph button, there we go. We're going to have to adjust this. Usually I actually start with with zoom fit, or sorry, zoom standard. But here, what we could probably do is, and I'll start with that. I'm going to go zoom 6. That's how I like to start. But we can see, we know it's going to be a quadratic, so we know it's probably going up, way up here and back. So let's see here. I guess when I'm figuring out my values here, I know that x, if I think about like a logical domain of the application, I know that x cannot exceed 22, right? I can't even get to 22, otherwise I wouldn't have a dimension here, right? It would be 0, and then I'd have a 0 area. That makes no sense. So what I'm going to do is I am going to change my x value to include that. So I'll go ahead and make this like 25, just so I can see the whole thing. I got a little bit of space, all right? Now my y value, sometimes what I like to think about is like, well, what if it was like maybe just a couple random dimensions? We know that it's going to be, how about like 12 times 10, right? That adds up to 22, and that's what 2 of these sides should add up to. So 12 times 10 is 120. How about I just go up to like 150, give myself a little bit of room? Okay, now when I graph this, hopefully I'll see it. All right, I can see the whole function here. So I did some general ideas here. Not that it's exact, but I just kind of picked a couple numbers that seem, hey, these are 2 decent numbers. Let's see what that area might be and give myself a little more room. Okay, so you could also do zoom fit, and that will also often set it up, but sometimes it doesn't always have everything, right? So I think about it like this. You can do the zoom fit and then adjust from there. It's up to you, all right? Let's continue. For what value of x is the area the largest? So what am I looking for? I'm looking for my maximum. Let's hit second trace. Ooh, love that one. And then we're going to go to maximum, which is number 4 here. And then what I got to do is, again, left bound, right bound. So I'm on the left side of that high point, that maximum. Arrow over, and this should be a bit of review, right, with our calculator. And then arrow up to the top, always moving left and right here, because moving the up and down arrows, it actually toggles between different graphs if you have multiple functions in here. If I hit enter, I get a maximum of 10.9, so we're saying 11, and then our y value is 121. So x equals 11, and this is what are the dimensions of the rectangle? Well, if x is 11, then well, what would my y value be? Well, if I plug it in over here to this guy that was already solved for y, I'd have 11 for the y as well. It's a square. That's not as fun, but we're going to get somewhere that's not a square. Don't you worry. You can ask for more fun. What are the dimensions of the rectangle? So 11 feet by 11 feet. And the maximum area was that y value, the 121, because that is our function. That's our a of x, right? So that would be 121 feet squared. Beautiful. Dunzo with that one. Yes, it's a square. That's kind of boring, but when we get into other stipulations, it starts changing it up. All right? But that's just our first example. If you need to, pause it and jot these steps down. If you're feeling okay with it, you're good. Alrighty, so we have a farmer is making 2 side-by-side enclosures and it has 200 meters of fencing. Express the area a of x as a function of the width x. And then what's the maximum total area of the whole enclosure that the farmer can enclose? Round your answers to the nearest thousandth and make sure, yo-ro, we ain't rounding along the way if we got to make some calculations. Leave those numbers in that TI-84 or TI-83 calculator. All right. So if this is x for our width, we would have then x for this one right here and x right here, right? Now, a of x, and I'm gonna jot some formulas over here. So we have our area, and we've got our perimeter again. And they give us information about the perimeter, which is the 200 meters of fencing. So not necessarily like the perimeter around the rectangle, because we also have to include this piece of fence that goes there, so it's the side-by-side enclosure, right? Well, my area is, again, going to be, I'll call this dimension y. Our area is going to be x times y. And that's all we have to go by right now. But we do have information about our perimeter. Our perimeter, or our use of fencing here, is going to be how many x's? 3x plus, and then we got 2 y's, so 3x plus 2y. And we do know that our perimeter is 200, so we can work with that. And it's going to be a similar process to before. And I want to make one little note here is setting up these 2 different functions. There are other ways of doing it. I've seen other videos or other teachers do it different ways. But the reason why we're separating this here is due to the application problems you're going to find yourself working with in AP Calculus. So setting up the two functions will have you ready to go when it comes time for those types of problems in your later class. All right. So once again, I'm going to solve this for y. So I'll subtract 3x, and I've got 200 minus 3x equals 2y, and I'll divide everything by 2. So I'll have y equals 200 minus 3x over 2. And I'm going to substitute that in for my y. So I'll have a of x equals x times 200 minus 3x all over 2. I guess I could have just written that right here. All right. Cool. Wonderful. No sense in writing it again. I should have just done that in the first place. Now, there's no real reason to multiply this all out. It doesn't tell us to. So I'm just going to leave it like that, and I'll plug it into my calculator like that. So let's do it. Pull out your calculator. Let's plug it in. Alrighty. So we've got it all plugged into the calculator here. One thing I do want to point out, if you have a calculator that doesn't give you the nice fractions, on your newer ones, you can hit alpha y equals, and you can choose a fraction. But in this particular calculator, I don't believe it has that functionality. So I had to use parentheses. You got to be real careful with that. You end up having to double up so that I get 200 minus 3x in my numerator divided by 2 as I'm plugging this in. So be very, very careful with that. Otherwise, it will not come out right. Alrighty, so I went and did the zoom fit method, which would be zoom 0. And like I said, you end up not getting the full graph every time. So we do still have to make some adjustments. So what it looks like is it's starting to get to our max here. We're pretty close. So if I go to my window and my X max is 25, I'm going to go a little more than double that. And I could actually do a little math in here and solve for that 0 and find out that it's going to be somewhere in like the 60s, I think. So I'm just going to go to let's just go to 75, okay? I could calculate my zeros, but I'm going with that for now. And then my maximum, it looked like it was going to need to go a little bit higher. So how about I go to 2,000 and we'll see how that is, okay? Again, it's a bit of a guessing game, but we can make some educated guesses, in my opinion. Heck yeah, we did it. All right, so we can see everything that we need. We can see both of our zeros. We can see our maximum. So when it says, what is the maximum total area of the whole enclosure that the farmer can enclose? We're not even asking for the dimensions at this point. We just want the max area. So, second, calc, maximum, that's number 4. Oops. Uh-oh. Oh, second, I forgot to hit my bounds. Second, calc, 4. I'm going to move to the left a bit because I can't really tell if I'm totally to the left. All right, I'm going to go even a little more. I remember my calc teacher's always like, make sure it's clearly to the left and clearly to the right. So I got to do that. It's ingrained in my memory, you know. I don't want to mess it up. All right. I want to make Miss Gilbert's mad. And then there we go. So my maximum would be 33 1/3. That's my x value is my dimension. This y value is not this y value. This is my function, my area function, my a of x. So this is my maximum area, which is 1,000. Oh, what was it again? I think it was 1,000. Yep. It says round to the nearest thousandth. So that'd be 6, 6, 7. Okay. I mean, we're talking area there. We probably could have rounded a little less than that, but we did it. That's what the directions asked for. I like it. That's awesome. And this is our meters squared. I hope I did the right units on the last one. Was it feet before? Now I'm wondering. It was feet. Okay, cool. I got in a panic. I thought maybe I changed the units. All righty. So there we go. We've answered the question. We're all good. That's all it was asking for there. Again, the zoom fit sometimes works great, and sometimes you have to make adjustments. So just be aware of that. All right. That was wonderful. So this one here, we're not asked to actually solve it or anything like that, but it's saying, how would this problem change if the farmer made the enclosure against a barn, let's say, or a shed, because it's a barn and a shed in this problem. All right, we'll say shed. Big shed. So, and express the area A as a function of the width x. Well, I still have these as my x, right? My x dimension. And then this would be my y, but what am I not needing? I don't need fencing on this side here. So now my area function still starts out as A equals X times Y, but my perimeter is going to be that 200 equals, and it's going to be 3x plus y. So when I subtract that 3x, I'm going to get y equals 200 minus 3x. So now my area function, when I substitute that in, is x times 200 minus 3x. So we're going to need less fencing, but we still have 200 meters of fencing. So we're actually be able to make a bigger area here for whatever's being fenced in. Okay, so we're going to be able to to do a little more with this one because we're using that shed as a part of the fenced in area, right? So that's how it would change this function. I'm no longer doing 2 times y, it's just 1 y dimension. And there we go. We've got our area. Didn't ask for anything else. I think we're good. I'm good with this video. That was a solid amount of application there. I hope you guys enjoyed it as much as I did, as much as Riverdog Jenny did. Make sure you follow her on the gram. And you guys have a fantastic day. All right. Adios.